so should not be like that much, because I think there is like only maybe Ishem. You have Anaconda in your PC already. Yeah. So basically, what I would do it like in live. So what we do is we do conda create. Okay. So I type conda create. I will call this workshop, and I want my Python version to be 3.9. That's it. Very simple. You can like say like 2.10, since we try to like to stay up to date. Now the last version should be like 3.15, something like this. So it is like a good way like to always try to use the most like recent version of Python, because everything is going fast and there is a lot of update all the time. So I type, and it will tell me blah blah blah. Do you want to install? Just say yes. We good. Blah blah blah. Super, super. And then what I do is I do activate my environment. To do this, to connect to my environment, I do conda activate. The name was workshop. Now I am in workshop. If I type Python, it should be, the version of Python should be 3.10. 3.10. Okay? If I import NumPy, should it be inside or not?
No.
Should not be inside. By default, there is no package. Now, what I do is I do install all of this. Ctrl D to exit, or exit with parentheses. I do install everything. Ask me if I do want to install. I install everything. And now basically is the time when you do all your conda install. You do console, your install of PyTorch, OpenCV, anything that you need, SciPy, any kind of library that you are working with. So once it's done, what you do is, the next step is you want to import the configuration associated to your conda environment, and to do this is the following. We'll name it workshop, because for some weird reason I tried to change the name, so we'll change the name for every time you see data env, you will call it workshop. Okay? So conda env export, no build, this, I forgot the name of this, but yeah, this symbol, and then the name of the YAML file that will represent the actual configuration of your conda environment. Okay? So now, if I type this, it will create a YAML file that will be the representation of my conda environment. So all the packages that I have are present here. So there is a lot of packages. And now, what I want to do is, I have my virtual environment in my PC, and I want to make sure that inside my safe images, I can access the same environment. Because when I'm developing locally, I'm using this environment. So when I want to run the script, I want to run the same script with the same environment inside the cluster. Okay? And to do this, what we need to do is the following. We need to use the recipe that I created inside the GitHub repo, and the recipe is very simple. You have Bootstrap from Docker, from which use an Anaconda official images, and some couple of lines, which is I will explain later. And the line are the following. So Bootstrap Docker, and this thing is just to say that I'm using Anaconda. Okay, it's like an environment with Anaconda already installed. You don't have to install Anaconda. I will be copying the file inside OPT. So the YAML environment that will be using to install everything. So this is the compact representation of my Anaconda environment. I will copy it inside the cluster, the image. And then what do I do is I change those variables. So basically, I need to change the name of my environment. I need to exactly tell the name of my environment. So in my case, the name was workshop. So workshop. This one also is changed. It's not data.env now. It's workshop.yaml, but it's working the same way. Same for this workshop. Same for this. So basically, this env name should be changed with the actual name of your environment. If your environment is called like PyTorch something, you call it PyTorch something. Okay? So this variable is equal to the name of your environment. Okay? And most exactly the name of this. All the time it will be equal to this. You will see inside your YAML that the name of your environment is created and at the current path. Okay? So now my recipe is changed. I changed the name of my environment. I just added things to create the conda based on my configuration. So basically what I'm saying is I will create the environment based on my YAML file. In locally I can create it. So for example, if I send you the YAML, so for example, if I send the YAML to Hisham, you can use it by just creating the environment using the YAML by installing the YAML. That's it. It's basically a conda line that allows you to create environment based on YAML file. And now the most important thing is this file, this line, which is run script, and it's basically the idea that every time I will run the image, this line of code will be executed first. So that's why I need to use run and not exec with those type of images, because I want to first run this command to activate the environment and then run my Python script. Because if I do not activate my environment, I will be at the base, and in the base I do not have the packages that I'm currently using. Okay? So now this recipe is the heart of everything. So once you have this ready, and you have your YAML ready with all the packages that you have in your Anaconda, everything should be fine. So now what we do is we create the actual image using the recipe. And the recipe is the following. Apptainer build, let's call it workshop, so to make sure that the annotation is now aligned. And this will create an image, stiff images with Ubuntu and Anaconda in it, with a Python environment that was locally used, and that will be inside it, because I give the YAML configuration of Python environment. That's it. And if I run, basically with Apptainer build, the name of your single file plus the definition of the file, as we did before. So now it will build, okay. So it is taking time. So now you see the step of installing inside the Singularity image. And when it's done, you will see that the Singularity image is giving you the info that the image is installed. So now it has been built. So you can see build complete, workshop.save. And inside this workshop.save, I can access my Conda environment. And basically that is the correct way to create a safe image that you can use Python with a specific environment inside it. That's the most easiest way. But sometimes all your packages cannot be installed with Conda, so you need to either redo the step and maybe try to do pip installed inside it, or what you can do is afterward you can change the zip file using what we call the sandbox that I will show you now. So basically we will create a representation of our images, which is basically a repo that will be created inside our PC that is called sandbox, and we will then be able to directly change inside it and connect with shell script to directly install packages. And then once those packages are installed, we'll recreate the zip file from the sandbox. So let me show you in live, so you can see. But first, let's exec the. Let's run. Let's run the script, and it's not called data amp. It's called workshop. Yeah.
We have 2 points, workshop.save.
Oh, yeah, maybe. Second. So let's try without sudo. Yeah, live demonstration, guys. It's always great. Donc, voilà ce qu'on va faire. On va taper la commande ligne par ligne. So, Apptainer, exec. It's called workshop, save, Python, .c, import, panda, print success. But you can see it printed success, so it means that the actual import worked. But if, as I mentioned earlier, if now I try to, for example, in our case, for the next steps, I will show you how to install another package, and the package will be XGBoost, for example. It's like a package that is used in machine learning to use boosting decision tree algorithm. It's very popular in machine learning, and if I do this, it will tell me there is an error because package already do not exist. And actually, the error wasn't that it do not exist because XGBoost if and yeah. So now it should tell me that yeah, module XGBoost do not exist because didn't install it. This makes sense. So now I will show you all once you have your Singularity with your Anaconda inside it, or you can create a new one with new packages inside it. And it's basically using Sandbox. So now let's go to the part where I tell you how to install Sandbox. So to create Sandbox, what we need to do is we need to use this command line. So Apptainer build -- sandbox. The name of the sandbox, so the name of the directory that we will create, that will be representing all the file and what it is inside the ingest. So let's say maybe we'll call it is like workshop sandbox. And it's based on either a recipe or a zip file. So if it's based on the recipe, it will directly install. If it's based on a zip file, it will just copy what is inside the zip file. And now you will have a hard version of your Singularity image inside a directory. So it will create, like you will see. So now, as you can see, there is inside my repo a repository that is called Workshop Sandbox, and it contains everything that is inside the zip. So it's like a mini OS with everything inside it. Okay? So now, if I want to change this, I can change it, and then from the sandbox, recreate the zip. Because Singularity or Apptainer allow us to do this. So now what I need to do to connect to this repo and to be able to run command inside it, I need to connect the shell, and I need to also add the writable flag. So everything that I will do will be inside it and will be written inside it. Yeah, so need to change the name. It's not data.conf, but workshop. And now I'm inside it. I'm inside the command line. Maybe I can zoom a bit. Yeah, now it's like, now you should now you should see more clearly. Okay, let's like let's keep this resolution. So now I am inside the singularity box. So what I can do is basically, I will tell you why I'm doing this later on. Just make sure that I am in the root of the image and not in the root of the current repo. Because if, let's say we do this, if I do ls, I will be inside my current repository. And I want to go back to the root of the image. So I just like do multiple cd to jump back to the root of the images. Now I am inside the images, as you can see. There is like everything that is inside. Okay? And now comes the actual magic. Because now, let's say I want to install something inside Conda. What do I do if I want to install something inside a Conda environment?
Activate preference.
Activate and then
I go to the environment.
So I go to the environment, I do Conda activate, run Conda init.
the name.
There is something to do bash ls.
Exactly. There is a thing that you need to do, a special command that you need to add before being able to run this command. Because if you just run this command and try to type conda activate workshop, this will not work. It will give you an error. And to be able to conda init and to be able to have a bash, to enable the bash inside the image, you need to, even if you type conda init, it will not work. It will give you a say that there is no bash that is linked. I cannot run script. I can run command inside. So to make sure that it is working, what we do is we use this command that was found inside a very dark place, very dark place inside many search and many Stack Overflow conversation. So this one, when you look at it, it's very simple, but this one allows you to, once when you're inside the singularity image, allow you to be able to use conda command inside it, basically. So once you tap this, specific command line, should give you nothing. And then when you type conda activate workshop, it should work. You should see workshop activated. And now what we can do is we can, for example, install XGBoost, for example. And then it will install it. And now, once this is installed, what do I do is, from the workshop sandbox, I want to recreate a new save, a new image. And to do this, very simple.
So every time we install a new package, a new zip is to be.
Yeah, the idea is every time you want to add a new package, you add a new save. You need to create a new save because the save is basically, so the best practice is to keep a sandbox and install everything inside it. And once you do update, you update the sandbox and then you recreate a save images. So that's the best practice. And then we recreate the singularity image using this command line. So Apptainer build the name of the new images, which is based either at the end of the command line, we just have either the name of a save file, either a recipe, or either sandbox. And in this case, this is a sandbox. Okay? And we will call this so it's not data env, but workshop sandbox, and we call this workshop new to not overwrite the previous one. And now we'll be able to build another SIF images that is based on the sandbox that we just created and we just updated. Oh, yeah. I'm still inside the sandbox, so I cannot use the command line. So I need to exit, and to exit there is like multiple ways. You can type exit and you out. You can also Control D, will also exit. So now, copying the exact command, I can now build the name of the new images based either on the SIF images, recipe, or sandbox. In our case, it is sandbox. Okay? Then I will be recreating. You will see that new SIF images will be created with the name workshop new. And now we will test with this one and try to import XGBoost, and you will see that XGBoost is now present inside the images. Build complete. So now let's test the same thing that we did earlier, but not with the workshop SIF, but workshop new, to see if there is actually the actual. Yeah. So now, remember with this one didn't work. When I type import XGBoost, it will print that the package is not installed. Yeah, module not found, blah blah blah. There is an error. So now let's try it. Same command line, but with the new SIF images. And now it should work. Success. As you can see, a success because we updated the SIF and recreated a new one. Okay? So that was the most challenging part, guys. Now the rest is less complicated. But the most important thing is this part. Being able to create your singularity image that is a version of your local Python environment that will be then copied with the SIF box inside the cluster. Because you want to run your code like with the exact same packages inside the cluster. And the way that the cluster is working is using Singularity. And so for this, you need to install a SIF image with the exact same packages. That's it. Is this clear? OK clear? Normal clear? Both clear? Question?
And if you need to work with C, C++ too?
The same is here, instead of Python, what you did to install inside the recipe. So here, basically, you do all of the things that you did inside your machine.
Okay.
All your package that you installed, all your command line, you do this inside.
So how many C files are there, like SIF images? Like in a workflow, how many SIF images are you have to type? Like, is there only one SIF image? Or?
But for example, during my PhD, I did, for example, say every 3 to 6 months I change images because either I updated packages or either I change the source code of some library. So if I change something in my local machine and I do use the code, I also need to update the SIF images. So
for a particular project, only one SIF at a time.
yeah, most of the time you use one safe images for one project. But sometimes when you're lazy, I get it. Sometimes you're lazy and since you know that inside these packages, this safe image, there is torch, and for example, you need only torch and OpenCV, you can reuse image. But basically, the correct way is one kernel and one safe. Okay, and in the production ready. So when you develop, let's say you have like 2 months of code development inside your PC, and maybe you change some source code of like Python, and what you do is you then recreate the sandbox with the source code changed. And now I will show you if you want to change the source code of, let's say, a Python code, a Python environment. So to change the source code, you need to go to the sandbox. So you go to the sandbox here. You go to bin. You go. Where is Anaconda located? Basically, you go to where Anaconda is located. Like if you do it locally, you can access to all the package that Anaconda installed. If I remember correctly, it's maybe in lib.
I think it's on OPT.
OPT? Is that, let's try OPT. Yeah, Conda. Yeah, you followed. Great. And if, for example, Conda lib, we should look for AMP. Basically, that's this place when we can have access to all the environment. Yeah, that's all the environment. There's one environment or one, and inside it there is all the packages. And inside there is lib. So this part is complex because this part is when you want to change the source code of a library. So for example, you are working locally with your Python environment, and then for example, you use some specific environment. Let's say in my case, I changed a source code of 2 libraries. I was working with no ODE, which is basically Python packages that allow you to work with ODE with PyTorch, and I needed to change something inside it. So I went inside the packages and changed directly the code there. And to do this, it's basically you go to lib, and then you will see all the Python packages inside it, everything that you use.
So after making the change, you have to again build.
Yeah, exactly. And then what you do basically is you change those files, you save, and then you rebuild. That's it. But the exact packages, normally we should see the name of it. Not sure why we're not seeing the names.
Maybe it's not there.
So Rashid, is there like a example project that we can do to keep to make the workflow like more? I mean, just an example homework. So is there a like example project inside the repo which we can do so that the entire workflow becomes clear?
The complete workflow?
Yeah.
I think I did put like a example with everything. Yeah, in the repo.
So that we can do on our own and probably have questions with us.
Yeah. It's basically somewhere here. So the packages, the Python library are somewhere here. I do not remember exactly. Maybe SB maybe. Yeah. No. Maybe another time. I will tell you exactly, guys, where it is.
Right.
But yeah, basically, if you want to change something like locally, you need to change it inside the sandbox. That's it. And now, once we have this, what we can do is we can now copy the sandbox to a cluster. And that's what we're gonna do now. And I will show you then how do we run code within the cluster with the sandbox. And then the tutorial will be kind of like finished. Okay? I will just okay. So now what we do is we able to copy the singularity box that we just created, and this one will be copied to the cluster. I will now show you how to copy this, and it will basically use the same principle that we see with the code. Just some lines are changed, but it's basically the same pipeline. So inside my home, inside the cluster, I have a file repo that is called containers. So I want to copy my zip file inside this repo. And I want to give the exact path of my zip file. So I will just use some utility from VS Code and copy the path. That's it. Now I'm copying the path. So home uven code hpc workshop new.zip. That is the full path of the images. That's it. And now I have everything that I need. I have the path of the zip images. I have where I want to copy this, and everything should be working fine. So now I just do pass dot the name of the script, which is copy image, and this will then be copied to the cluster. And so before I copy, maybe I will show that I'm not messing with you guys. Maybe I already have the images. So let's see that I do not have the images already. And to do so, let's hope that it will give me access when I come back. And when I go to GPU machine, and I go to containers, all of those files are safe images that are used in the past. And as you can see, there is no workshop. There's no workshop.zip, but those are all the images that I did use previously and I'm currently using. Okay? And to let you know, guys, you can use safe images from other guys. So for example, you can use my images. If you link the exact path, you link my path of the images, and then you can use inside your own session. Because one thing inside the cluster is that everyone can see other screens. So that's one of the it can be an advantage, but the disadvantage is that if you have like sensible like code and data, it's not a great idea to directly copy and paste. You need to ask Jean-François to isolate your session, because by definition I can have access only in read, not in change. I cannot change the code, but I can have a read access to all sessions that are present inside the cluster. So I can have access to Isham session, I can have access to everyone's session if I know your name. Okay?
Yeah, but how will we understand that if your .safe image is useful to us? Like,
Yeah, that's the idea. That's the problem is that if you do not have documentation, you cannot know if.
so do you create a documentation for every image you?
The best would be to do this, but you know, you know the. But sometimes I do let the singularity file recipe inside it, so you know what is inside my image with. For example, I do use the conda env, the YAML. So if you check the YAML env, you know that I have, for example, Torch, OpenCV, and so on. So. But yeah, for like the corrector, it would be like nice to have like a README for each time you are developing. Say in this version, I just added this in terms of like some sort of like a log file with the version of the security box for yourself, so you can keep up with the change. Okay.
But you, well, if you are finding your data, the data is your local PC.
Yeah,
and
great question. So, for example, as I mentioned earlier, I have one place for container, one place for dataset, one place for code. And the place for dataset is in dataset,